Hi, welcome to this Blender video tutorial entitled Blender Lighting Spot Lamp. The Blender Spot Lamp is the most complex and versatile of Blender's lamp types. To demonstrate Blender's Spot Lamp, I have placed in my scene a modeled sculpture and a base placed on a flat plane. The sculpture has a gold material attached to it, the base a mottled blue material, and the plane a cherry wood texture. In the World Editor, I have added a blue blended sky gradient. I have split my 3D editor into two windows, placing the UV image editor on the right, and have set the render output to display the rendered image in this UV image editor. I'll render the scene. As the scene has no lighting objects, the sky is displayed, leaving the sculpture, base, and plane in silhouette. I'll place my 3D cursor in the top view and add a spot lamp object. Notice that from top view, the spot lamp appears to be a circle of light. I will switch to front view. Here we see that the spot lamp is a cone of light emitting from a point. I'll move it up to about the height of the camera. I'll then rotate the spot so that it is focused on the sculpture object. I'll switch to side view and rotate the spot lamp here as well. The spot lamp is now fully focused on the sculpture object. I'll render the scene. The result is a rather hard-edged circular beam of light illuminating the objects and producing a hard-edged shadow. I will click on the Object Data icon in the Properties panel, which displays the spotlight's many controls. The Preview panel shows a dim, hard-edged oval-shaped light surrounded by darkness. Like all of Blender's lamps, a spot lamp can be changed to any of the Blender lamp types by clicking on the lamp type buttons. Its color can be changed by adjusting the color swatch, and its energy or intensity can be adjusted by increasing or decreasing the energy control. Like all Blender lamps, the spot lamp also has a negative, this layer, specular, and diffuse checkboxes. Like the point and area lamp objects, the spot lamp has a fall-off, or a point in space that the lamp's energy or intensity is 1/2 of the original. Like the point lamp, the equation which determines the fall-off can be changed, as well as the fall-off distance. Note that as the fall-off distance controller level is changed, the length of the spotlight cone represented in the 3D viewport changes accordingly. Here I will set the fall-off distance to 10 Blender units and render the scene. Because the fall-off distance is shorter, the illumination of the objects is dimmer because the fall-off is quicker. The spotlight has a sphere attenuation checkbox, which limits the extent of the lamp's light beam to a distance setting. The shape of the beam is still a cone, despite the name of the sphere. Unlike fall-off, the sphere's attenuation progressively limits the intensity of the light to total darkness. In other words, there is no light beyond the extent of the distance setting when the sphere checkbox is checked. I'll checkmark the sphere checkbox and render the scene. Because the sphere linearly falls off from full to 0 over the distance length, the object illumination is much dimmer. I will uncheck the sphere checkbox and raise the energy level to 3 to compensate for the shorter fall-off distance of 10, and then render the scene. Blender's spotlight performs in many ways like a theatrical ellipsoidal reflector spotlight. In fact, many basic lighting techniques have been adopted from theatrical lighting methods. The spotlight has a number of shape controls. The first of these is size, which by default is set to 45 degrees. This refers to the light beam width angle. Increasing this angle setting creates a wider beam of light, and decreasing it creates a narrower beam of light. You can see this represented in the 3D viewport as I raise and lower the size control level. I will lower the beam size angle to 10 degrees. Note in the 3D viewport that the beam of light crosses only a portion of the sculpture. I'll render the scene. I'll set the size to 30 degrees, and in wireframe display in the front and right side views, move and rotate the spot so that the beam of light from the spotlight is striking the sculpture from a much higher angle. The blend setting controls the softness of the beam. By default, it's set to 0.15, which results in a hard edge beam of light. Note in the 3D viewport the inner ring representation as I raise and lower the blend control. I'll set the blend at 0.9 and render the scene. The beam edge is now much softer. The beam can also be square rather than circular by checkmarking the square checkbox. I'll checkmark the square box and render the scene. The beam is now square in shape, both in the rendering and in the 3D viewport. I will uncheck the square box and re-render. One useful feature is Show Cone. I will checkmark the Show Cone box. The Show Cone displays a transparent cone in the 3D viewport. This cone is only visible in solid shading mode. I'll press the Z key to enter solid shading mode, and the cone is now displayed. This allows one to see exactly which objects or parts of objects lay within the cone of illumination. The final set of shape controls are the halo controls. A halo is a volumetric effect. It creates a sense of solidity to the light beam, much as if there were dust or smoke in the air. I'll checkmark the halo box, leaving the default settings, and render the scene. The beam of light now has a sense of volume. Note that the halo effect is affected by the fall-off effect. I'll set the fall-off distance to 25 and re-render the scene. The intensity setting, which by default is set to 1, controls the density of the volumetric effect. I'll set the intensity level to 0.25 and render the scene. The step setting controls the sampling of shadows when the halo is in effect. The higher the steps, the more samples, and thus the softer the shadows. I'll set the steps to 5. Pay particular attention to the 2 outermost shadows cast by the sculpture. I'll then render the scene. The shadows are much softer and spread. The halo effect is often used in combination with a coloring of the light. I will change the light color to a warmer color by reducing the amount of blue to about 0.5, and then re-render the scene. To demonstrate the spotlight shadow controls, I'll delete this spotlight and add a new one. In front view, I will move it to about the height of the camera, and I'll rotate it so it's focused on the sculpture. I'll do the same in side view. I'll increase the energy to 1.5 and then render the scene. Here we can clearly see the shadows cast by the sculpture. By default, the spotlight has its shadow casting properties activated. It is possible to turn these off by clicking on the No Shadow button. The default shadow producing mechanism for the spotlight is buffer shadows. The spotlight is the only Blender lamp object that presents this buffer shadow option. The point, sun, and area lamps are limited to ray traced shadows only. Buffered shadows are generally less accurate than ray traced shadows, but generally render much faster than ray traced shadows, especially when a low number of samples is selected. Some modelers will use the buffer shadows during the development of a model and use ray-traced shadows for the final rendering. Both the ray-traced and shadow buffered shadows have a color swatch, which by default is set to black to determine the shadow color, as well as a This Only Layer and Only Shadows checkbox. When the buffer shadow option is selected, a number of other shadow options are displayed. Some of these settings are legacy settings from older versions of Blender that need to be available to render older Blender files. The default buffer shadow type is called Classic Halfway. The quality of the buffer shadows, its hardness, softness, and transparent effect, is the result of both a sampling and filtering process. The various permutations here are quite complex. Generally speaking, the greater the sampling and the better the filtering, the softer the shadow. Here I will use the Classic Halfway buffer type. I'll set the sample buffers to 4, the number of samples to 6, and I'll use the default box filter, setting the softness to 10. And then I'll render the scene. The sculpture shadow is now softer. I'll switch to the deep buffer type. I'll set the sample buffer to 9 and the size to 1024. I'll set the filter type to Gauss and set the softness to 18. I'll then render the scene. The shadows are even more softer. I should note here that with such high sampling, the shadow buffer rendering can take as long or even longer than the ray traced shadows. When the buffer shadow option is activated, an additional set of controls called clipping are available at the bottom of the shadow panel. The clip start and clip end settings control the start and end points in the spotlight's cone of light where shadows will be produced. Note in the 3D viewport the line indication for the clip start as I change the clip start value. I will place the clip start in the middle of the sculpture and then render the scene. Note that the rendering does not display any shadow cast by the top half of the sculpture. I'll switch to ray traced shadows and render the scene. The ray traced shadow setting produces a very accurate and by default hard edge shadow. The ray traced shadow setting has two different methods for generating shadows, adaptive and constant QMC. The constant method is used to calculate shadow values in a very uniform and even and distributed way. This method results in a very good calculation of the shadow value, but it's not as fast as the adaptive QMC method. However, constant QMC is more accurate. The adaptive QMC method is used to calculate shadow values in a slightly less uniform and distributed way. This method results in a good calculation of shadow value, but not as good as the constant QMC. The advantage of using adaptive QMC is that it is generally much quicker. With both the adaptive and constant QMC methods, the higher the sample number, the softer and more transparent the shadow. I will choose the constant QMC method. With the soft size set to 1, I will set the samples to 3, and then render the scene. The sculpture now casts a very soft and fairly uniform shadow. Both my sculpture and the table plane have a slight mirror effect on their materials. I'll select the sculpture object, go to the Materials Editor, and turn on the mirror effect. I'll do the same with the table plane object. I'll then render the scene.